Hello everyone, I'm going to discuss about WSO2 APK and how you do API management with WSO2 APK. So before I start the session, I will walk you through Kubernetes native API management, how you do basically API management in Kubernetes environment. When you want to expose your services to outside world in a Kubernetes cluster, there are multiple ways that you could do that. So exposing your services to outside world through the node port is one such option, and there are other ways that you can also do. That includes expose your services to outside using the load balancer and expose your services to outside using the Ingress as well. So out of these methods, Ingress is one of the most famous method because some of the features that it provides. So let's see how we can expose your service to outside world with the Ingress. So let's assume you have your Kubernetes cluster, and inside that particular cluster you have multiple services. So these services may include, as per this particular example, station information service, ticket booking service, and the payment service. These different services are deployed as separate application pods, and they are usually represent as a service in a Kubernetes. So what we have done here is, from the Ingress level, we have pointed multiple services, so that from the based on the path we can identify what is the actual service that we should dispatch the request, and Ingress will take care about routing that part. So that is how it works in this environment. So for the Ingress, there's a specification named Ingress Specification. With that specification, we can provide how we can do basic routing, whether it's based on the host name or whether it's based on the path. Likewise, we can provide additional routing details to Ingress. So Ingress specification is quite common, and there are like multiple implementations out there, including Nginx, Traffic, and some other implementations. So people started using this. So if you look at the Ingress sample, it will be something like this. As you can see here, you start with the version of the API and then kind, and there are some additional metadata that you can provide, and also a specification, and then you can write rules. So when you write rules, you can decide what attributes you use to determine the routing options. So it can be based on the host, it can be based on the path, and based on the path or host, you can route it to different places, and you can do some load balancing, SSL termination. So that kind of things you can do with the Ingress specification. So there are some limitations associated with the Ingress specification. So if I start from the beginning, this Ingress specification primarily focus on the HTTP and HTTP traffic only. But if you have other protocols such as binary or any other protocols, most of the time it won't work. So there is one such limitation. So please remember, when I discuss about limitations, I'm not going to discuss about the vendor extensions. So these limitations and these points are organized based on the actual Ingress specifications. There are some other platforms which provide additional capabilities on top of Ingress specification using vendor annotations. So I'm not going to discuss about these things right now. So when I discuss the limitations, I'm primarily focused on the Ingress specification. So then other thing is, when it comes to load balancing, capabilities are somewhat limited. You can't do advanced load balancing, advanced routing with the Ingress specification. And also when it comes to routing, it's mainly based on the path and host name. So you cannot use other parameters such as headers and other like complex calculations when you make routing decisions. And also when it comes to security, it mainly supports SSL termination. But if you look at most widely used security protocols like WSO2 or other security related stuff, that won't cover in the Ingress specification. And also when it comes to custom rules, so additional rules on top of what is available capabilities, there's no native support for custom rules in the Ingress specification. And also, like I mentioned earlier, there are multiple vendors who implemented these missing features using the vendor annotations. But when you do migration, so when you move one vendor to another, these vendor extensions will cause some pain, because you cannot easily move from one vendor to another because they have done these vendor extensions differently. So most likely you will be end up in a situation where you have to write entire configuration from the beginning because of these annotations. So that's a problem. So then due to these different vendor annotations, you will have to have some kind of a learning curve because you have to learn these things. So in addition to that, with the Ingress specification, we don't have a clear role-based access control model. So if you remember the previous configuration that I demonstrated, in that configuration we have multiple attributes. So that includes port, host, and there are some specific path related configuration. But if you look at the real world scenario, most of the time this host name and the port of the gateway or the load balancer, so these kind of things are determined by the admin users or cluster operators, like high privilege users. So at the same time, if you look at the path configuration, so for example, I am developing my shopping cart application, so I need to add shopping cart path to this configuration and route that request to my server. But in this case, I don't need to mess up the port configurations or the gateway certificates, and likewise these configurations are not relevant to me. But if you look at the Ingress specification, all these configurations are in a plat file. So if you get access to that file, you can do anything. So that is again one such limitation where we have when we have like a structured role-based access for this configuration, it can be a problem. So that is again one such problem. So due to these limitations, after some time, way back in 2019, Gateway API Specification introduced. So this is mostly done by the same people who were working with the Ingress specification and all, mainly because of these limitations we had. So the idea is to provide and develop comprehensive and adaptable solution for the traffic management. Basically address all the limitations that I discussed before. And it's a completely community-driven initiative. There are like multiple groups and users involved with this effort. So they are collaboratively work to implement Gateway API specification. So with the Gateway API specification, they have multiple concepts. So you see here the resource model for the Gateway API specification. On top you see the gateway class, and then the gateway, then you see different route. So if we go back to previous RBAC example that I was explaining, with this particular resource model, we can address that exact same use case. Because if you look at the infrastructure providers, they can template the class based on the gateway class. And when cluster operators configure or run actual gateway, they can decide how they run the gateway. Basically setting up port, hostname and other things. They set up actual gateway. So that is the cluster operator's role. So then comes the application developers who develop these shopping cart applications, payment applications. So they are basically developing applications or services that they need to expose to outside. So in that case, they can simply refer to gateway, and within the gateway, they can implement a TLS route. So they don't get any permission to modify the gateway or gateway class, but they can simply write their route and link that to gateway. So that way, it's very easy to implement a proper RBAC and build up a proper resource model. So that is the one of the main advantage of the Gateway API specification. So with this Gateway API specification evolution, most of the Ingress implementers started to adhere this specification. And at the same time, this Gateway API specification discuss mainly about the gateway, which is the main entry point for your cluster traffic. So almost all the requests that are coming to your Kubernetes cluster coming through this particular gateway, and this specification discuss about that gateway. So API management implementers also thought this would be ideal place to apply gateway related quality of services related to API management as well, because this is the main traffic entry point. So why we are not doing API management related quality of services at this layer? So that is the mindset behind API management implementers, and they also started adapting Gateway API specification. So with that, multiple API management vendors started working on Gateway API specification, and try to support that Gateway API specification. So at WSO2, we also started working on that, and we decided to support Gateway API specification. So with that in mind, we implement product called WSO2 APK. Okay, so then let's see what is WSO2 APK and why we wanted to have something like that. So if I discuss about the APK capabilities, we made basically API related artifacts first class citizens in the Kubernetes ecosystem. So what does this mean? So let's say when you work with the Kubernetes CLI, you can type commands like kubectl, get APIs, get pods, something like that. So we made APIs first class citizens so that you can interact with the kubectl command like you used to do for any other artifact, and you can simply deploy APIs and API related other artifacts as well. So in addition to that, our gateway can act as Ingress gateway and handle the incoming traffic for your APIs as well. So in addition to that, we do support API related developer workflows and API product management and API full lifecycle management as well. So in addition to that, we do also care about security monetization, subscription management, observability and monitoring, which are again related to API management as well. So then if I go to feature list or the implementation of the APK, so APK gateway is built on top of Envoy proxy. And to the configuration part, we use the CNCF Gateway API specification that I discussed before. So when it comes to developer portal and the back office capabilities, those features we are using WSO2 API Manager, which is again like a battle tested API management platform, which covers full lifecycle API management. And you can deploy WSO2 APK in any Kubernetes cluster or your laptop or private cloud or mega cloud. So in addition to that, you can also run multi-environment setup or multi-tenant setup. So for example, if you have requirement to run internal, external gateways, we do support that. If you have geolocation based different data centers, and you can deploy separate data planes with the WSO2 APK as well. And then if you want to have different data planes with the one control plane, we do support that as well. And it's a 100% open source one, comes under Apache license as well. So if I tell you a little bit about history of APK, so we have like onboarded few users into APK, and so APK introduced based on some of our own experience, because we were using WSO2 APK since 2021 in our own Choreo deployment for as a API gateway. And with that experience, by 2022 we thought, okay, it's good idea to like productize this and release it outside as a product. So with that in mind, we started working on APK, and we did our APK 1.0.0 GA release in September 2023, and last April we did APK 1.1.0, which is compatible with WSO2 API Manager 4.3 as a control plane. So that is a bit of history and the so far what we have done. So then if I give you a quick overview about WSO2 API platform for Kubernetes and how it works with WSO2 APIM, as you can see here in this diagram, you see you have your delivery channels or the clients here. So then when they want to interact with your services, they mainly come to APK data plane, which will have three main parts: configuration service, rate limiter, and the gateway. So gateway will connect to your internal namespaces where you have your services deployed. So those are represented as MS1, MS2 and MS3. So which means microservices, namespaces 1, 2, 3. And also APK data plane can be configured with WSO2 API Manager, but it is not mandatory. But if you want, you can set it up with WSO2 API Manager as a control plane. So in addition to that, APK can work with multiple logging, monitoring, tracing platform, as well as it can work with different analytics and business insight solutions. And APK installation comes as a Helm chart. that you can install in your Kubernetes cluster. After you install it, you can directly interact with the Kubernetes client. And for the code enhancement, we do provide VS Code plugin, and also APK supports CI/CD integrations with different pipelines. It could be like Jenkins or Git Actions, or any implementation that you could use. We do have few reference implementations as well available in our documentation. So all these things together, we call it APK platform, and it can work with multiple different other components and the solutions as well. So now let's see how we can deploy API on WSO2 APK. So if you want to install WSO2 APK, go to WSO2 documentation page and go to APK page. And when you follow the quick start, you will find set of free requests that you need to follow. Then based on that, you can do the APK installation. So once you install APK, you can create API application and other API related artifacts. So let's see how we can do that. So to do that, I'm going to go to this folder, and first I will execute my command kubectl get pods -n prod. So this will list out all the pods available in my production namespace. So as you can see here, there are multiple pods running. So I have installed WSO2 APK in this namespace. So as you can see here, we do have different gateway related components, gateway runtime, IDP related component, rate limiter component. So likewise, almost all the components that are required to run APK properly. So my setup is working fine now. So now what I'm going to do is I'm going to create API based on the Open API specification that I have. So let's see how we can do that. So this is the demonstration flow I'm going to try. So I'll start with the API definition. Basically it's an Open API file. Then I'll take this Open API file and generate APK configuration out of this configuration. And then I will enhance this APK configuration further by adding some rate limit policies. And after that, I will be generating Kubernetes artifact for this API. And then finally, I'll be deploying this API artifact into my Kubernetes cluster. So that is the plan. So let's start with the API configuration. So let me open my VS Code, and if you go here, you can see my hotel reservation Open API file. So I'm going to use this file and generate APK configuration using this file. To do that, I'm going to execute curl command. So basically with this curl command, it will connect to my APK configuration service and generate configuration or the APK configuration based on provided configuration. So this is the command I am going to execute. So I pass my hotel reservation service JSON file, and I'm going to call APK configurator and ask it to generate my configuration. So once I execute this command, as you can see here, it will generate hotel reservation API configuration file. So if I copy this file and trying to start creating APK configuration, I can do it like this. So I'll be copying here. Okay, so this is my configuration now. So now what I'm going to do is I'm going to enhance this configuration further by adding rate limit. So I'll set my request limit as 5 and 5 requests per minute. Okay, so now I have enhanced my APK configuration. So now I am going to generate Kubernetes artifact or the Kubernetes custom resources that we can deploy in my Kubernetes cluster by passing this configuration. So why we need this configuration? It is because with the Open API specification, you cannot define API management related quality of services such as policies, business policies, rate limit and other information. So to fill that gap, you need to build APK configuration. It's a very easy to understand one. So this is my VS Code editor. So there's a already built extension available. So once you install that extension, it will do the syntax highlighting and code suggestions as well. So I have installed that here. That is why I get rate limiting and request per unit, all these things as suggestions. So you can also install that. So now I'm going to exchange this generated configuration and get Kubernetes artifact for this API. So I'll clear it out and I'm going to call again config service with the hotel service JSON file as well as the APK configuration that I generate, and ask it to generate hotel CRD zip file. So I have executed this part, and now as you can see here, it will generate hotel CRD zip file. If I open it here, it will open like this, and let me go to VS Code and open that as well. So I have opened my VS Code, and so here you can see like a few different files. So I'll go through these files and explain what are the roles of these files. So if I'll start with the configuration config map, so it will basically have some metadata related to API and open API definition for this API as well. So then we have this HTTP route configuration. So like I mentioned earlier, this is directly coming from the Kubernetes Gateway API specification. So based on that specification, we generate HTTP route with multiple different paths, hostname, and all other details. So basically actual API routing logic based on the HTTP route. So then we do have other artifact called API. So with the API, what we do is that we will store some additional information that we cannot directly represent with the HTTP route or the some CRDs that are coming in the Gateway API specification. So that include the API name, API type, and organization and other API management related data, not really the routing part, but the API management data. So in addition to that, we do have rate limit policy, because in the Gateway API specification, they mainly discuss about the routing part, not policies or API management quality of services. So due to that fact, we had to introduce this rate limit policy, which is again come as a CR. So this CR will represent policy, and it says how many requests you allowed within a minute, that kind of configuration. So then finally we have backend CR as well. So this backend CR is mainly about how your backend representation. So what is the actual port it's running, what is the actual host name, and that detail. So all these files together represent API. So now I have created that. So if I type ls command, you can see this directory is there. So now I can apply this newly generated API into my Kubernetes cluster. So before doing that, I will execute kubectl get APIs -n prod. So as you can see here, there are multiple APIs. So this API I already deployed, so it's there, but I'm going to run it again anyway, so it will override my whatever the APIs I have. So to do that, I'm going to execute kubectl apply -f and this directory which is 2b. So this is the directory, and I'm going to provide my namespace as prod. So once I execute this command, what it does is it will create all these artifacts. So basically it will execute this all these custom resources, and now if I go to kubectl get APIs, you will see the updated APIs. But in this case, it's almost same, so there won't be any update. But if there are update, it will deploy new API, and now it is available. So as you can see here, there are multiple APIs. So the first one is the user defined API. So other APIs are system APIs that need for the internal communication between APK different component or some different services exposed to outside users to get token and other operations. Okay, so now I have created my API. So now it is time for me to obtain an access token and invoke this API. So let's see how we can do that. So to do that, I'm going to execute this command. So once I execute, so it's a very simple command. Basically, I'm going to call my token API with the credential, and I'm trying to obtain an access token. So now if I type echo $token, then I should be able to see the token. Okay, so this is my token. So now what I'm going to do is using this token, I'm going to invoke my newly created API. So to do that, I'm going to refer to token like this, as a variable, and I'm going to invoke my newly created API. Okay, so once I invoke API, I get this request, and so let's say I will invoke this API a few times. 1, 2, 3, 4, 5, 6 times. So it will rate limit, because if you remember, when I create a policy, I said maximum allowed requests per minute is 5 requests. So rate limiting is working, and at the same time, if I change the token, then I will see the token errors as well. So that is how APK work basically, and how it can invoke, I mean how we can invoke this created API. So now let's see how we can work with the control plane. Basically, what is the relationship between the control plane and data plane? So to demonstrate that, I'm going to use WSO2 API Manager. So I have login. I'm trying to log into API Manager. Use admin. Okay, so when you create API from the data plane, it will come here as a API, so that you can manage it from there onward. So far what I did was I worked as a basically API developer. I created, deployed it, and invoked it. So next flow, what I'm going to do is I will do this part, and once I done all these things, it will publish this API entry to control plane. So as a product manager, I can go to control plane and do certain enhancement and start consuming this API. So let's see how we can do that as well. Before doing that, I'm going to delete this API so that I can create it from the beginning, and at the same time I will delete that from the publisher as well. So most likely, if there are no any subscription, it will allow me to delete. Let's see, I can do that. Okay, so there are some subscriptions already available. So I'm going to remove that subscription and create that from the beginning. Okay, so I'll go to applications and go to default application and subscriptions, and I'll delete the subscription. Okay, so now if I go back to publisher, it will allow me to delete this API because now we don't have any subscribers. Okay, so I'll delete this API. Okay, and at the same time I will delete this same API from the Kubernetes side as well, just to demonstrate this flow properly. I will type kubectl get APIs, and this is my API. I'm going to delete that. kubectl delete API -n prod. So now this API got deleted. So if I run kubectl get APIs again, you won't see that API. So now I'm going to create this API again, basically executing that same command that I used to create this API, kubectl apply -f. So now I execute this command, so you can see all these definitions like the HTTP route, all these things are newly created. So if you go to this diagram, what I did was I created this API in the data plane, so it will push API to control plane as well. So now if I go to publishers, publish as of now we don't have any APIs. Now if I refresh this, you should be able to see that newly created API. So you can see this API created, but it is in the created state. So now as a product manager, what I'm going to do is I'm going to enhance this API further and make it available for external users. Okay, so this API, as you can see here, it's already deployed because from the data plane side, we already actually deployed it. So if I go to portal configurations, I can go to this I can add this description, I can add image, then I can enhance this API further, and then go ahead with whatever things I want to do with the API. Okay, so I won't go, I will not change anything, any of these things, but there are certain things that I can change. I can add business owners. I can set the subscription related policies. I can add the documentation. So if there are already created document, you can see this document here. And in addition to that, I can add comments. So if you go to runtime configurations, you will see you can't change it because this API developed and deployed from the data plane side. So from the control plane side, we can't change it because it's already deployed. So if you go to deployment section again, you see you can't do any deployment related work because it's already deployed from the data plane side. And as a API product manager, you don't need to worry about that. So now I'm going to try out section and generate internal key, and I'm trying to get reservation details. So let me try to execute this one. Okay. Okay, it's a course error, so I'm going to copy this gateway URL because it's a certificate issue. I'm going to paste this URL and accept the certificate. So I should be able to. Okay, so now I should be able to invoke API. Okay, so I can invoke the API and get the response. So then as a API product manager, I can publish my API. So once I publish my API only, it will be visible to API consumers. So let's see how we can do that. So I'll go to developer portal, the same one, am.developer portal, and I can log in as admin. Okay, I have already logged in as admin. So if I go to APIs, I can't see any API. So now I'm going to publish this API. So once this API publish, it will appear on the developer portal, and external consumers can come here and consume this API. So now if I refresh this API, I can see the API, and then again if I need to try out, I can try out, or else I can subscribe to this API and start consuming this API. So basically that's how it works. Yeah, so this is how it works in the data plane side. So now let's see some analytics related details and how we can basically configure analytics monitoring and tracing for WSO2 APK. So in the demo flow, we came up to this point where we have the control plane and data plane both, and data plane will push things into control plane. So next we will see how we can do configure WSO2 APK as a gateway for WSO2 API manager and configure analytics monitoring and tracing as well. Thank you very much.